Okay guys, so this is the assignments that I assigned you today. Today is, no, it's not Tuesday, it's Wednesday, February the 20th. Okay, these are your homework assignments for tonight. You were assigned page 3 and 4. Okay, just reminding you, we've already done all this. This was the video before. Page 3, numbers 2 and 8. And page 4, numbers 4 and 6. 2 and 8 are getting real comfortable, hopefully, with limiting an excess reagent. 4 and 6 on this page are percent yield. The reason I really want you to do this, and the reason why I'm filming a video of myself working out your homework problems, is because we did not get time in class to do these calculations and for me to see them and give you feedback. Okay, so I just need to be sure you have something to go from if you don't know where to start or what to do. So percent yield, remember the formula for percent yield is the actual yield over the theoretical yield. Okay, the actual yield is what you actually get in the lab. Okay, the theoretical yield is what you theoretically produce from stoich calculations with the limiting reagent. Okay, so remember my tip for you, if you know the limiting reagent, then you will, sorry, I just saw a phone call come through and it totally distracted me. If you know your limiting reagent, that's going to be what you use for all stoich problems after that. Okay, so, oh, and then times 100. So number 4, let's just jump right in. Notice I've got the reaction already balanced. Number 4 says when 6.57 grams of iron is reacted with excess HCl, hydrogen gas and 14.63 grams of iron 3 chloride are obtained. Calculate the theoretical yield and percent yield of iron 3 chloride. Okay, so it's telling me I want the percent yield of this. It gave me a number about this though, so this is my actual yield. Okay, this seems a little vague. Most of the time when I write you percent yield problems, I will tell you, in the experiment, 14.63 grams is actually produced. I'll try to give you more information. Okay, but if you see a given about the product that you're calculating percent yield on, that is your actual yield. We will never give you theoretical yield because we're going to expect you to calculate that out with the stoich using your limiting reagent. Okay, so you're not going to do anything with this number yet. This is the given that you're going to start your stoich with, okay, because it's the given on your limiting reagent. So I've already done that. I've already set that up. So I took 6.57 grams of iron, did some stoich magic to get grams of iron chloride, and I got 18.9 grams of iron chloride. This is my theoretical yield. Right? In a perfect world, a perfect experiment, no spilling, perfectly calibrated balance, no evaporation, you would theoretically produce 18.9 grams of iron chloride. But when they did this reaction in the lab, they only got 14.63 grams. Remember, your actual yield is usually going to be less than your theoretical yield. Okay, so now we've got our two variables that we need. We've got our actual yield and our theoretical yield. So now we just plug it into the formula. Actual yield goes on top, 14.63. Theoretical yield goes on the bottom, and you get 77.41% yield. Okay, try to take your decimals 2 places into the hundredths unless your directions tell you otherwise. Okay, so this is a pretty straightforward percent yield calculation. The only thing that was maybe tricky was really realizing that that's your actual yield. So again, if I don't say your actual yield is 14.63 grams, then you're just looking for the given about the product that you're solving percent yield for. Okay? Okay, number 6 is tricky. Okay, it says you need to produce 10 grams of iron chloride. Okay, so this is telling you in the lab you need your actual yield to be 10 grams. If the percent yield of this reaction, let's say every time you do this reaction, your percent yield is 50%. So it's giving me percent yield. It's giving me what I want my actual to be. So I'm going to be solving for my theoretical yield. But even more detailed, it says how many grams of iron do you need to start with. Okay, so my steps, I'm going to say the steps that we're going to be doing, and then I'm hoping that it kind of clicks once I start working it out. So this is going to be my actual yield. This is my percent yield. I'm going to solve for my theoretical yield of iron chloride, and then I'm going to need to decide how many grams of iron I need to reach that theoretical yield. So I'm just going to do a stoichiometry problem at the end. Okay, so number 6, I need to produce 10 grams. That's my actual yield. Okay, my percent yield was given to me, and it was 50%, right? Which, when you're using that in a calculation, it would be 0.5 equals my actual yield over my theoretical yield, which I don't know. Okay, so when you solve this problem, you get 20 grams theoretical yield of iron chloride. Okay, and if you aren't sure how I solved that problem, you could do two things. You could set 0.5 over 1, and since they're equal to each other, you can cross multiply and divide, or you can isolate theoretical, because that's your variable. Let's just say that's x, right? So you would multiply both sides by x. This cancels that out, and then you would be dividing by 0.5. Okay, and when you divide 10 divided by 0.5, you get 20 grams. Okay, you could also just use common sense, right? Percent yield is 50%. You need 10 grams. You're going to need 20 grams to start out with as your theoretical yield. Okay, so cool. We have our theoretical yield, but this is not what it asked me for. It says, how many grams of iron do I need to start with? So grams of iron is my wanted. This is my given. So it's just a stoich problem now. 20 grams of FeCl3, and then you go all the way to grams of Fe. Okay, so I am going to fill this in really quick. I'm not going as detailed as I should, like this is just a rounded molar mass. I'm going to drop moles of FeCl3 on the bottom. The minute I see moles are given on the bottom, that's my red flag that this is my mole ratio step, and I want moles of iron. So I have 2 moles of iron. Let me show you where I'm getting this number, these numbers. 2 moles of iron and 2 moles of FeCl3. And then 1 mole of iron. That's the only step, guys. You use your coefficients. 1 mole of iron and 56 grams in 1 mole. So 20 times 2 times 56. Divide by 161. Divide by 2. Please notice, guys, that I did divide by and divide by. Okay? Anything on the bottom you keep dividing by. If you multiply that, it's going to mess up your order of operations. Okay? And so I get 6.96. Gosh, I've like completely lost track of my sig figs. So 3 sig figs, sweet. I just got that from that number right there. Grams of iron. Okay, so this is how much I'm going to need to react. That gives me a theoretical yield of 20 grams and a percent yield of 50% at 10 grams, an actual yield. Okay, so hopefully that helps. This last one, this number 6, is pretty advanced. Okay, it's a pretty big extension. Number 4, if you understand that, then you're doing pretty good.